who is here with us today. Sorry, if you're here, you can take the stage.
Outstanding. Thank you so much. Okay, I've got a little bit of sun going on in my office today. So I'm going to go ahead and share my screen and hopefully you can see my program right there. Give me a thumbs up if you can, Olga.
Yep.
Yep, excellent. All right. So hello and welcome. And a huge thank you to the Advanced Air Mobility Institute for inviting me to speak with you today. I'm honored to be here to share a snippet of my passion for AAM with you. The National Aviation Authorities Network. I was tempted to abbreviate that mouthful to NAN, but that sounded too much like my favorite Indian bread, so we'll go with the network instead. And I'm going to discuss their roadmap for AAM. So between There we go. So between April 28 and 29 of this year, 2025, five national aviation authorities from the United States, Canada, Australia, New Zealand, and the UK signed a declaration of intent to collaborate on a roadmap for AAM aircraft type certification. Because, and I quote, industry innovation in civil aviation must be met with forward thinking regulatory frameworks and safety oversight. The network aims to foster cooperation, learning, and sharing of best practices by working in partnership on common and emerging challenges. On June 17, 2025, at the 55th International Paris Air Show, the network announced their roadmap for AAM aircraft type certification. Before I begin highlighting the key points of this document, my legal disclaimer. This is the first edition. This is a living document, expected to evolve in the future to include different and more information. Today's presentation is but the beginning. The network's goals include working towards the following six key principles: using a unified and strategic approach, and AAM inclusive bilateral agreements. This will allow aircraft manufacturers to maximize the transferability of their aircraft across the five nations. Let's start with Principle 1, Safety and Innovation. This is a safety-first framework, with the network balancing safety with technological advancement. Expect to see the implementation of comprehensive risk management strategies, safety management systems or SMS programs, as well as assurance best practices. Principle number 2, harmonized type certification, that utilizes a three-phase approach, with the phases occurring concurrently but quasi-independently. Phase 1 involves the use of performance-based requirements. Phase 2, the network converges on requirements that differ between national authorities, as you're going to see in a minute. And Phase 3, the network applies a mutually accepted means of compliance, having created consensus standards. Principle number 3, collaboration and alignment between the network and other key authorities that have active domestic AAM certification projects. The goal being to reduce overall validation effort, as well as reduce the certification burden, not only on the validating authorities, but also the OEMs. Principle 4, collaborative multi-authority validation between the type certifying authority and the other authorities in the network to coordinate requests by the OEM for certification across all five nations in the network in a one-to-many collaborative program as opposed to the traditional one-to-one model used today. Principle number 5, incremental approach, known as the crawl, walk, run method. Starting with piloted AAM with one pilot on board, then evolving to remotely piloted AAM with the pilot on the ground, and finally autonomous AAM with the machine being simply monitored by a human. And lastly, principle number 6, AAM inclusive bilateral agreements. These already exist but might need updating to encompass AAM, or they might need to be created anew. The network would also like to add new members going forward. Let's look now at each authority's contributions, starting right here in the United States with the Federal Aviation Administration, our FAA. In the Code of Federal Regulations, 14 CFR Part 23, but more specifically, Part 2117 Bravo, as the type certification approach for special class aircraft, utilizing airworthiness criteria to identify additional airworthiness requirements for AAM. In 2024, the FAA released the Special Federal Aviation Regulation, SFAR 120, as it is now known, for powered lift aircraft, which includes new regulations and guidance for pilot certification, aircraft certification, and operations, and 14 CFR Part 194. There's a draft advisory circular 2117-4, type certification of powered lift, with Appendix A containing airworthiness criteria for powered lift design. In conjunction with all of this, there's a draft policy statement dealing with the safety continuum for powered lift. This policy statement establishes certification levels of powered lift and their associated system safety and aircraft performance targets based on the aircraft capability and operational risk. This policy is intended to account for the broad variances of powered lift type certificated under Part 2117 Bravo. Next up is a draft policy statement dealing with special class rotorcraft. Type certification for special class rotorcraft will follow the same procedures as those for other special class aircraft under Part 2117 Bravo. These are meant for electrically powered rotorcraft with more than 2 main rotor systems, sometimes even 3 or more. It is expected that the 5 nations will adhere to assurance best practices, such as these aerospace recommended practices issued by the Society of Automotive Engineers. And now on to Australia. CASA, the Civil Aviation Safety Authority, will use their equivalent to the US 14 CFR 2117 Bravo in their civil aviation safety regulations to establish the type certification basis for special class aircraft, supplemented with airworthiness criteria as required. CASA will use FAA-published airworthiness criteria and may also develop their own when requirements are unique. To date, Amsel Aero's Vertia received an experimental airworthiness certificate from CASA. In 2024, Joby Aviation from the United States applied for type certification validation in Australia, leveraging the bilateral agreement between the FAA and CASA that already exists. And now on to Canada. Transport Canada will also use their equivalent to 14 CFR Part 2117 Bravo, their Canadian aviation regulations, to establish the type certification basis for AAM aircraft, supplemented with airworthiness criteria as required. Much like CASA in Australia, Transport Canada may use FAA-published airworthiness criteria and may develop additional ones when requirements are unique. Limosa has started the type certification process in Canada for its Limo Connect aircraft, an 8-seater eVTOL and eCTOL, and plan to enter into service in 2028. Horizon is also in the running with a hybrid electric eVTOL, the Caveret X7. And off to New Zealand now. While the Civil Aviation Authority, the CAA of New Zealand, has not yet type certificated any eVTOLs, they plan on utilizing the flexibility within their regulatory framework to accept appropriate airworthiness design standards on a case-by-case basis. Our own US-based WISC has conducted flight tests in New Zealand. Wisk Aero's Cora, their fifth-generation aircraft, is an all-electric autonomous four-seat air taxi designed for passenger transport. Last but certainly not least, the UK Civil Aviation Authority. They have aligned with the European Union Aviation Safety Agency, EASA, and adopted EASA's SC VTOL as their prescribed airworthiness standards for type certifying AAM. EASA is on its second issue, released in 2024. It will be critical that the network coordinate and align with the UK CAA on common airworthiness standards because differences currently exist between EASA's SC VTOL and the FAA's AC 2117-4. Even though they both provide a tiered approach to the type certification of AAM aircraft that is aligned to the safety continuum. Still in the UK, we see the use of certification specifications, EASA's CS23, which outlines the minimum requirements for certifying small airplanes in these categories within Europe. While CS23 is not legally binding, it serves as a guideline for manufacturers to demonstrate compliance and obtain a type certificate. Despite differences, the good news is that both 14 CFR Part 23 and CS23 are performance-based, and they're essentially aligned in their airworthiness requirements. The UK CAA also uses Special Condition E19 for electric hybrid propulsion systems. So next steps. How will this roadmap be implemented? Well, Annex A provides an indicative timeline. The network focus is to work together to achieve these milestones as early as practicable. The network plans to expand itself with new authorities while enhancing collaboration and alignment with the 5 current nations and ICAO and EASA. Speaking on behalf of others in the AAM industry, I am thrilled to see such collaborative action and transparency and engagement and innovation. The AAM future is quite literally taking off. Thank you for your attention.
All right, that was a great presentation and a great example on how the new fields are pushing authorities to collaborate together and